students, we have to understand the next concept that is called self-inductance and mutual inductance. Let me draw the diagram. That time I will just ask you. All of you concentrate students. If I take AC voltage, this is what AC voltage, okay? Voltage is what continuously vary. That is called AC voltage, okay? And if I take a coil, okay? If I take a coil, students, abhi now this coil having number of turns, suppose N, okay? This coil is called, students, now you have to understand this coil is called inductor. This coil is called inductor. What is the symbol of inductor? L. What is the symbol of inductor? L. What will happen when I switch on this particular voltage, and if I suppose, if I keep key, if I switch on, what will happen? Current will start flowing. Okay, current will start flowing. When current starts flowing, what will happen here? We observe that due to current, here magnetic field is produced. That is a property of electromagnetic induction, as you know, magnetic field due to electric current. So students, when current is flowing, what will happen? Magnetic field is producing, and that magnetic field, definitely magnetic field is represented by the uh, letter phi. Phi is called magnetic flux. Okay, magnetic flux. Student, this is AC voltage. No, what is AC? Most of the electronic students know what is AC means. What? This is alternating voltage. Agreed? Means what? Up, down, up, down, up, down. Matlab, for this position, voltage is less. At this position, voltage is maximum. Again, 0. Again, minimum, 0. Maximum, 0. Minimum. Means what? I want to tell you that this voltage is varying. Due to this voltage is due to this change of voltages or voltage, current is also varying. Current भी vary हो रहा है. If current is varying, then phi is also varying, because as current increases or decreases, magnetic field also increases and decreases because there is a change in current. So that means we can say phi is directly proportional to current. Matlab, I want to tell you magnetic flux is directly proportional to current because here we use what? Alternating voltage. So we observe that if there is a directly proportionality, then definitely proportionality constant will come. Proportionality constant will come, multiply by current, and that proportionality constant is called as inductor or inductance of that particular coil. Remember this. So what is phi is equal to L multiple of I. Remember this. Now students, what I will do here, I will differentiate with respect to time. Now you know the derivative. So d by dt, L is constant. So here also d by dt of I. So students, we got d phi by dt equal to L di by dt. But since, what is d phi by dt? According to Faraday's second law, is a E. That means induced EMF, or what is the formula for induced EMF? L di by dt. Remember this formula, students, because this is very important formula. So students, this is a formula for induced EMF when current is passing through the coil of inductor L. L di by dt. The students, in the exam, no, they will ask what is coefficient of this. L is called coefficient of inductance, self-inductance. This L is called coefficient of self-inductance. In the exam, they will ask what is defined L. So what is definition of L? Is what? E upon di by dt. E upon di by dt. Like this you have to define. So L, coefficient of self-inductance, is defined as the ratio of induced EMF to the rate of change of current. What is definition of mutual self-inductance or coefficient of self-inductance? Is a ratio of EMF induced to the rate of change of current. Okay, this is the definition. And students, what is the unit? Unit of L. Unit of L is Henry. Remember this name, Henry. What is the symbol of Henry? H. Okay, what is unit of L is what? Henry, H. Okay, understood? So this is a simple explanation about self-inductance and coefficient of self-inductance. Now let us understand the mutual inductance. So students, I am going to draw the same diagram. This is what AC voltage with a coil. Okay. One more coil I kept, I took over here, and that coil is connected to what? Direct wire. Okay. This is what AC voltage. Okay. This is what current I. Okay. Now students, what will happen? All of you concentrate. When current is flowing through this coil, this is called primary coil. Suppose P1, P2. And this is called secondary coil, S1, S2. I am not telling, those electronic students will understand that particular diagram will come. I think so transformer. It's not a transformer. Transformer I will explain afterwards. This is simple. I took one coil. I attached AC voltage. Okay. And then I took one more coil and I connected to the direct wire. So what will happen? There is a gap. There is no connection. There is a gap between two coils. There is a gap between two coils. Now student, what will happen? Current is flowing through the primary coil. Due to current, here magnetic field will produce. Here magnetic field will produce. And this magnetic field will cut by which coil? The secondary coil. Matlab there is called mutually attachment of this coil with this particular primary coil. There is no direct contact. First, initially current will flow. Again, I am going to explain. Current will flow. Due to current, magnetic field will generate in the primary coil. This particular magnetic field will cut by which coil? Secondary coil. And according to Faraday's law, when magnetic field is cut by the coil, then secondary current will flow here. So students, this is called IS, secondary current. This is called primary current. Definitely, most of the students are asking, is this current is same? Matlab, IP and IS are they same? No. No students, I will tell you the formula. This is called primary current. This is called secondary currents. Means I want to tell you about flux produced in secondary coil. This is called flux. So students, flux produced in secondary coil is directly proportional to current in what? Primary coil. Agreed? This is very important derivation. But this is very important, this particular expression. Flux in the secondary coil is directly proportional to current in primary coil. But current is flowing into primary coil. जितना ज़्यादा current in primary coil, उतना ज़्यादा flux in secondary coil. Remember this. So students, now if I put here proportionality constant multiplied by IP. So students, what is this proportionality constant here? It is called as M, not L. L is called self-inductance. Okay, and here mutual inductance is represented by capital M. So student, this is the formula for mutual inductance. Phi is equals to M into IP, where M is called coefficient of mutual inductance. Okay, because this is what? Mutually attached. So student, now I am going to take the differentiation with respect to time. D by dt of flux in secondary coil is equals to M d by dt of what? Current. So students, since what is according to EMF formula for Faraday's law, second law, E is equals to what? D phi S by dt. So EMF produced in secondary coil, EMF produced in secondary coil is what? M multiplied by d by dt of primary coil. This is the formula for EMF induced in a secondary coil. So students, now in the exam they will ask, what they will ask? What is M? So what is M students? What is M? M is what? ES upon DIP upon DT. Don't ratta the definition. Understand the concept and then you can prepare your definition. So what is definition for coefficient of mutual inductance? Coefficient of mutual inductance is defined as is the ratio of EMF induced in the secondary coil to the rate of change of current into the primary coil. This is a very important definition of primary and secondary. You have to use that word. Otherwise, if you write only definition, no one will give marks. So what is coefficient of mutual inductance? Coefficient of mutual inductance is defined as the ratio of EMF induced in a secondary coil to the rate of change of current in the primary coil. Understood students? Hope so you understood that this particular concept is